Find the domain of followings. Suppose f of x equal to sin inverse x plus tan inverse x. Your domain of sin inverse x is -1 to 1 closed interval, and domain of tan inverse x is R. We know that if it is f1x plus f2x, then domain of f equal d1 intersection d2. Intersection of these two is -1 to 1 closed interval. Again, f of x equal to tan x plus tan inverse x. We know that domain of d1 is R minus this, and domain of d2, that is tan inverse x, is R. We know that d1 is subset of d2. As d1 is subset of d2, d1 intersection d2 is d1. So domain of f equal d1, that is this, the domain of this function. Domain of sec inverse 2x. As you know that the domain of sec inverse x is modulus of x greater than equal to 1, or x belongs to minus infinity to minus 1, union 1 to infinity. So obviously 2x belongs to this, or modulus of 2x greater than equal to 1. So modulus of 2x equal to 2 into modulus of x greater than equal to 1, modulus of x greater than equal to 1 by 2. So x belongs to minus infinity to minus 1 by 2, union 1 to 1 by 2 to infinity. So domain of this is minus infinity to minus 1 by 2, union 1 by 2 to infinity. Again, domain of cosec inverse of x by 3. We know that domain of cosec inverse x is modulus of x is greater than equal to 1, same as in sec inverse. So as modulus of x by 3 is greater than equal to 1, so modulus of x by 3 greater than equal to 1. So modulus of x greater than equal to 3. So x belongs to minus infinity to minus 3, and 3 to infinity, minus 3 and 3 closed. Again, if f of x equal to this, so domain of this function, domain d1 is minus infinity to minus 1 by 3 to 1 by 3 to infinity, as the modulus of 3x greater than equal to 1, so modulus of x greater than equal to 1 by 3. So basically x belongs to this, and d2 is R. Now intersection of these two is d1, as d1 is subset of d2. So range of domain of this function is this. If we consider f of x equal to sec inverse 2x, it is cosec inverse to 3x. Same modulus of 2x greater than equal to 1, so modulus of x greater than equal to 1 by 2, that is minus infinity to minus 1 by 2 closed, union 1 by 2 closed to infinity. Again, domain of this function, again modulus of 3x greater than equal to 1, again modulus of x greater than equal to 1 by 3, that is minus infinity to minus 1 by 3, and 1 by 3 close to infinity. And the intersection is d1, as d1 is subset of d2. As you know that if it is 0, it is 1 by 2, it is 1 by 3. Again it is minus 1 by 3, it is minus 1 by 2. So minus infinity to minus 1 by 3, this again 1 by 3 to infinity. Again another is minus infinity to 1 minus 1 by 2, 1 by 2 to infinity. So obviously their intersection is minus infinity to minus 1 by 2, union 1 by 2 to infinity. So d1 is here, d1 is minus infinity to minus 1 by 2 and 1 by 2 to infinity. So obviously d1 is subset of d2. So its domain is d1. Again, sin inverse x plus sec inverse x by 2. Here d1 is minus 1 to 1 closed interval. For sec inverse x by 2, it is minus infinity to minus 2 and 2 to infinity, minus 2 to closed. Now their intersection is pi. Minus infinity to minus 2, 2 to infinity, it is minus 1 to 1. Their intersection is phi. So f of x is not defined for all x belongs to 1. So it is not a function, as you know that this is not the rule for a function, real function, not the rule for a real function. As you know that if f is a function from a to b, both a and b must be non-empty. But here the domain is an empty set. So it is not the rule for a function. It cannot be ruled for the real function particularly. Again, another question, if cosec inverse x plus cosec inverse y plus cosec inverse z equal to minus 3 pi by 2, find the value of this. We know that cosec inverse is a mapping from this to this. So obviously the minimum value of cosec inverse x is minus pi by 2, and the maximum value is cos pi by 2. Cosec inverse x is. Similarly, cosec inverse y is this, cosec inverse of z belongs to this. As it is minus 3 by 2 and its minimum value is minus pi by 2. So this holds when each individual equal to minus pi by 2. So cosec inverse x equal to minus pi by 2 at x equal to minus 1. Similarly, at y equal to minus 1, it is minus pi by 2. Similarly, z equal to minus 1. As you have to find out x by y plus y by z plus z by x, it is 3. Find the principal value of followings. The assignments to you. Before this, first we have to remember all the domain principal value, all the ranges of the principal value ranges of the inverse trigonometric function. That is sine inverse, that is sine inverse of x equal to theta. Obviously theta belongs to minus pi by 2 pi by 2. Cos inverse 0 to pi. We have to remember this. Then if x is positive, for particularly if you consider sine inverse, if x is positive, value lies between 0 to pi by 2, that is theta. If x is negative, it is minus pi by 2 to 0, that is minus theta. For cos, the range is 0 to pi. So for x is positive, it is theta. If x is negative, it is minus pi minus theta. So you have to remember these domain and usual domain and ranges of the principal value branches of the inverse trigonometric function. Then you can solve the assignments. So these are the assignments. You must solve it. There are some doubts of students which I want to. That is assignment 1. There are many doubts from assignment 1. On the question number 5, most of the students have doubts in question number 5 from assignment 1. If sine inverse whole x whole square plus sine inverse y whole square plus sine inverse z whole square equal to 3 by 4 pi square, find the value of x square plus y square plus z square. We know that sine inverse x lies between minus pi by 2 to pi by 2. So obviously by squaring in each term, sine inverse x whole square lies between 0 to pi square by 4. As their addition is 3 by 4 pi r square, that is 3 into pi square by 4. So each individual must be equal to pi square by 4. So this condition holds when this equal to pi square by 4, this equal to pi square by 4, this equal to pi square by 4. And obviously sine inverse x equal to plus or minus pi by 2, sine inverse y equal to plus or minus pi by 2, sine inverse z equal to plus or minus pi by 2. So x equal to plus or minus 1, y equal to plus minus 1, z equal to plus minus 1. We need x square plus y square plus z square, which is equal to 3. Another question. This is also from assignment 1, the question number 4. Most of the students have doubts in this question. If x, y, z, t belongs to minus 1 to 1 closed interval, and sine inverse x plus sine inverse y plus sine inverse z plus sine inverse t equal to 2 pi, then find the value of x square plus y square plus z square plus t square. As you know that sine inverse x lies between this. So obviously the maximum value of sine inverse x is pi by 2. And the addition of this force is equal to 2 pi. So each individual must be pi by 2. So above condition holds if each individual equal to pi by 2. So x equal to 1, y equal to 1, z equal to 1, t equal to 1. That is x square plus y square plus z square plus t square equal to 4. Another doubt from assignment 1. 1 minute. Find the domain of sine inverse of x square minus square root of x square minus 1. F of x is defined if this lies between minus 1 to 1. Squaring both sides, we get 0 less than equal to x square minus 1 less than equal to 1. As you know that square of a negative part is always positive, so 0 to 1. Adding 1 in each term, it is 1 to 2. Modulo x square is same as modulus of x square. So by taking square root on each term, it is 1 less than equal to modulus of x less than equal to root 2. So we know that a modulus a less than equal to modulus less than equal to b. X belongs to minus b to minus a union a to b. So x belongs to minus 2 to minus 1 closed interval union 1 to infinity. Sorry, 1 to 2 root 2. So domain of this function is minus 2 to minus 1 closed union 1 to root 2 closed. Some other doubts. assignment. Many of the students have doubts. Sine inverse of root 3 plus 1 by root 2 and sine inverse of root 3 minus 1 by 2 root 2. We know that sine 15 degree equal to sine 45 degree minus 30 degree. So we can write sine 45 degree into cos 30 degree minus cos 45 degree into sine 30 degree. That is sine A minus C, sine A cos B minus cos A sine B. Sine 45 degree 1 by root 2, cos 30 degree root 3 by 2. It is again 1 by root 2, it is 1 by 2, which you can write root 3 minus 1 by 2 root 2. Implies sine pi by 12, sine pi by 12 equal to root 3 minus 1 by 2 root 2. If it is sine inverse of root 3 minus 1 by 2 root 2, as this value lies between minus 1 to 1, it is and it is a positive number, so value lies between 0 to pi by 2, that is pi by 12. Similarly, we know cos 15 degree equal to, in the similar manner, it is root 3 plus 1 by 2 root 2. Cos 15 degree equal to sine it is same as sine 75 degree root 3 plus 1 by 2 root 2. As you know that cos 90 minus 75 equal to cos 15 cos 90 minus theta sine theta. So if there is a question sine inverse root 3 plus 1 by 2 root 2, it is 75 degree, which is equal to pi by 3 plus pi by 12, that is pi by 3 plus pi by 12, 60 plus 15, that is 5 pi by 12.